Today we are going to see about stop and wait ARQ. ARQ stands for Automatic Repeat Request. It is a data link layer protocol. So in data link layer, it's responsible for line discipline, flow control and error control. So when there is error, we need to the receiver request for retransmission from the sender. So flow control, we have stop and wait and sliding window protocols. So today we are going to see about stop and wait protocol. So in stop and wait ARQ, one frame is transmitted at a time and then we get acknowledgement for that and then the next frame is being transmitted. The other one is sliding window ARQ where several frames can be transmitted at the same time. So this is about the stop and wait ARQ. There is a sender and a receiver. WT represents the waiting time. So here the one data is being transmitted. Then we get an acknowledgement. After receiving the acknowledgement only, the next data is being transmitted from sender to receiver. So the total time, so the sender sends the data in this place, the receiver receives in this instant. So this duration, this time delay is the propagation delay. The total time propagation delay from the start of the data transmission to the end of the end of getting acknowledgement is called the wait time. So every time after a data is being transmitted, it gets acknowledged and then the next data is transmitted. So like this it is. So we get data 1 is transmitted. So we have windows in the sender side and receiver side. The frames are numbered. We know the data is in the form of frames in data link layer. The frames are numbered alternately ones and zeros. The sender has to send one particular frame at a time, which is represented by the variable S. And receiver has to receive one particular frame at a time, represented by R. So S is equal to 1 in the sender side. So in the sender side, S is equal to 1. And in the receiver side, R is equal to 1. Data 1, frame 1 is being transmitted and we get acknowledgement 0. The number near the acknowledgement tells which frame is expected next by the receiver. So ACK 0 means the sender has to next send frame 0. So now S is equal to 1, frame 0 is being transmitted and then frame 0 has to be received. Now R box is equal to 0. So frame 0 is received and then it gives an ACK 1 like that. So next S becomes equal to 1. So it changes to S is equal to 1 and R will be equal to 1 now. Since 0 is acknowledged, R is equal to 1 now. So in that way it proceeds. So one data, its acknowledgement, next data, its acknowledgement, like the data are transmitted one by one at a time. So next is about sliding window. So this is our sliding, this is related to sliding window ARQ. So in stop and wait ARQ, what happens when a frame is damaged? So data is transmitted, data 1 and acknowledgement, its acknowledgement. Then data after the acknowledgement is received, the next data is 0 is transmitted, its acknowledgement. Next data, the frame is lost. The data 1 is received, but it is not received properly in the receiver side. So it gives a NAK meaning negative acknowledgement. So again, S remains in 1 only. So it retransmits the frame 1 again. And then the receiver gets the frame 1 and gives an acknowledgement for that. Lost frame. So same thing when a frame is lost. So this data 0 is lost. The timeout is reached. Timeout is twice the waiting time. The waiting time is the time taken for the data to be transmitted till the acknowledgement is received. Twice the waiting time is the timeout time. After the timeout period is expired, the data 0 S remains in 0 itself. So the data 0 is being retransmitted now. And then we get an acknowledgement 1. So when lost frame, the data is retransmitted after a timeout period. The same for lost acknowledgement. The sender is not going to know whether a data is lost or an acknowledgement is lost. So the data is received here. ACK 1 is lost here, but the timeout period has expired. So it retransmits the data 0. But since the receiver expects data 1 next, it receives data 0, so it discards that and again sends the ACK 1. Now the receiver knows that the acknowledgement is lost, so it retransmits the ACK 1 here again, which means the next data 1 will be transmitted. So next is lost frame and lost acknowledgement. So this is about stop and wait ARQ, where one frame is being transmitted at a time. It is received. That one frame is received in the receiver. Acknowledgement for that one frame is done. And after that again the next frame will be transmitted. Frames are alternately numbered ones and zeros. And the efficiency is very less for stop and wait ARQ because we use the dedicated link for one frame, its acknowledgement like that, which takes more time and bandwidth, so it's not much efficient compared to the other ARQ protocols. Thank you.